So we're first, and Eric and I are going to talk about redesigning the technical communication service course for Gen AI. And I'd simply start by saying that we're living in strange times. There are bills in the state legislatures in Utah and Iowa that are meddling with general education requirements, which typically include technical communication. These bills hope to change how we teach writing by adopting a great books approach focusing on American exceptionalism. I suspect these bills have a chance of succeeding, if only because it's easy to distort what we do in college writing classrooms. Meanwhile, nearly every university is struggling financially. In addition to just trying to make ends meet, some universities have rescinded admissions offers because of the uncertain future of research funding. At Penn State, we have a new budget model that will hopefully help us manage in a time of austerity. It rewards credit hours versus numbers of majors or other ways of counting. This new model should work for the writing program because 18,000 students a year generate 60,000 gen ed credit hours. If a heightened political climate and financial challenges were not enough, enter generative AI, which really does seem to be something new and different for us to contend with. And it's not only teachers who are struggling. Our universities are struggling with making institutional policy, thinking about academic integrity, supporting teachers and students, and more. Gen AI is exciting to many of us, but also extremely challenging and, of course, troubling at times. I'm going to talk more generally about the service course and some shifts we might want to make. Eric will then do a deep dive on prompt engineering to help us imagine more concretely how one aspect of Gen AI might fit into the future of the service course. We know a lot about teaching the service course. Our pedagogy is rich and measured. For evidence, all one needs to do is click through 40 years of conference proceedings published by the CPTSC. The question we're wondering about is how to evolve the service course to keep it relevant for today's world. Any approach should surely retain what we already know about running a service program and teaching its courses, but the service course should also address new directions for working with AI robots. These new directions will need to be accompanied by changes in policy and practice. Let me start by saying that the service course is a particularly challenging site for the curricular integration of Gen AI. That's because the service course is where our new teachers begin. And in addition to learning how to teach technical communication, many are also learning how to teach in a computer classroom. It's also a course where we want some disciplinary coherence so that the teaching experiences of people in our programs, including graduate students, make sense in a job interview. We ask the service course to do a lot of heavy lifting. I train everyone at Penn State who teaches the service course. New teachers of technical communication take a weekly practicum, and it uses a standard syllabus. After completing the practicum, teachers are free to make the course their own, assuming they continue to take a rhetorical approach. My hope is that all of the teachers continue to cover Gen AI issues, but we don't mandate topics. In my version of the service course, the scaffolding is based not on genre, but on complexity. Rather than working through, for example, a proposal, a progress report, recommendation report, and presentation, the course discloses what students need to know over a series of assignments, starting with basic concepts and building to more advanced ones. So the sequence of assignments can appear to be scattershot, but everything fits together to serve our instructional goals for teacher training and students. The assignments include a usability memo, job application package, technical description, instruction set, and internet guide. Nothing here is unusual or idiosyncratic. And thinking about the integration of Gen AI, my approach to scaffolding by complexity is one option, and maybe a good one for many service courses. For example, the course could review basic concepts, explore tools and platforms, review how Gen AI is used in different fields, including writing, teach prompt engineering, and discuss ethical issues. And you could scaffold by complexity to drill down in particular areas. If you were teaching prompt engineering, you could start with understanding how AI models process prompts and then move to writing clear and concise prompts, using markdown elements, creating multi-step prompts, using context to improve responses, explaining techniques for refining prompts, testing and iterating prompts, and even managing open-ended questions. Scaffolding by complexity has many benefits for learners, including building confidence, promoting retention, and enhancing understanding. A second approach to scaffolding for the service course relies not on complexity, but on temporality. A temporal approach aligns with phases in writing workflows. Something most of us are thinking about is the where of AI. Where exactly should students use AI in the process of learning how to create technical communication? This question is going to occupy us for some time to come, because using Gen AI as a writing machine or a writing resource is a complex activity for many different reasons. Even a seemingly straightforward answer is not so simple. Most resources on writing with Gen AI say that people should use it to draft content. But writing teachers know that one function of a first draft is to help writers figure out what they want to say and how. If you understand first drafts as a rich site for invention, you will probably tell students not to use Gen AI for first drafts, despite the popularity of this advice. I'm still in the process of exploring the best ways to integrate AI into my version of the service course, but here are some things I do. In the job application package, students use Gen AI to help them find job ads and learn about companies. For job ads, we use 4 categories for prompts. General prompts, as in find full-time technical writing positions in Pennsylvania. Platform-specific prompts, as in find technical writing jobs in Pennsylvania listed on LinkedIn. Industry-specific prompts, as in find technical writing jobs in healthcare in Pennsylvania. And skill-specific prompts, as in find jobs for technical writers with experience in software documentation. The prompting categories for learning about companies include general information, culture and values, financial and market position, job-specific information, company policies and benefits, and industry competitors. For the technical description, we use Gen AI for research and drafting support. Students can prompt Gen AI to ask questions that can help them find a topic of professional interest or to demonstrate that there are many ways to describe the same process or product. We also ask Gen AI to create an outline from a draft so that writers can see more clearly how their draft is organized. In peer review, students then compare the robot-generated outline with an outline created by a peer. For the instruction set assignment, students prompt Gen AI to respond to a draft of their introduction using advice for drafting introductions from our textbook. We're using Gen AI in other ways too, but these examples should give you a sense of things, at least a preliminary sense. I'm going to stop here and let Eric continue with the subject of prompt engineering.
Uh, Thank you, Stuart. I'm going to make an attempt to share my slides here, so bear with me for a sec. I'm wondering if folks can see my slides. Yep, seems like it.
Yep.
Awesome. All right. So, as Stuart mentioned, the question that faces us is where uh, for generative AI? Where in our curriculum? We're pretty focused on the service course, the technical communication service course, but where in the service course, where in the writing process? And so one of the candidates for pedagogical interventions that we found very promising is the topic of prompt engineering. At first glance, prompt engineering seems like a strong choice for incorporating AI pedagogies uh, and incorporating it into the technical communication service course, perhaps in technical instructions, the technical instruction assignment, or whatever variation of it that we're using. Um, it seems that initially like a perfect fit. Technical instructions have long been a hallmark of our field. They are widely used in programs across the country. Those courses feature a high degree of standardization, and technical instructions in general are highly conventional documents. They're structured documents, so they lend themselves to generative AI applications. However, as Stuart and I showed in our article that we wrote for JBTC, along with John Dan Johnson Aola, naive prompting or naive approaches to creating technical instructions can lead to inaccurate and disastrous results. And I'm sure all of us have seen humorous and sometimes not so humorous examples of the errors that ChatGPT can make. This is one of my current favorites, although you folks probably have your own favorite examples. So I'll let you take a moment and recall your favorite inaccuracy or hallucination or mistake. Uh, so we are approaching the problem of prompt engineering from a skeptical place. Uh, on the one hand, there's a welter of research showing that prompt engineering improves results. This statistic here comes from a study by Vatsal and Dubey from 2024. It was a survey of prompt engineering strategies. They covered dozens of different methods, categorized them, rated them, and drawing on the research from when they were published, tried to evaluate their effectiveness. And you can see, just as one example, chain of thought, which I've abbreviated here as COT, which is a prompting strategy, shows considerable improvement from basic prompting. Results, pardon the grammar here, this is um, a quote from the article, results as big as 39% improvement for mathematical problem solving and 26% for common sense reasoning. And these results are not out of line for the kinds of strategies that we see in the research. One of the problems with these studies, however, is that the problems that they're looking at, the tasks that they're measuring when they're trying to establish the improvement in the from prompt engineering, is the problems are all very simplistic. They're either basic math problems or basic logic problems. Something like based on a few pieces of information, correctly assign ages to all a group of fictional siblings, or perform a series of math operations correctly so that the result, is the correct result. And these idealized situations are not reflective of the kinds of tasks that technical communicators need to perform. And so there is a competing strand of research. And, if you look up prompt sensitivity in Google Scholar or something like that, you'll see a large number of studies that are finding problems with prompt engineering. And this is a pretty good example from Thomason and Klasky 2024. They write, while some prompts perform marginally better, overall performance tends to be heavily influenced by random factors, and small changes in the prompt can lead to unpredictable outcomes. And so what we're seeing here is, and other researchers have identified problems with the phrasal order, with the word choice, and even with formatting and including punctuation or non including punctuation can produce wildly different outputs. based on very small factors in the initial prompt. So this prompted us to take a skeptical approach to prompt engineering, so-called prompt engineering. Um, we think the term is a misnomer. Engineering implies a careful type of precision that yields results based on trial and error. The prompt engineering that we've been experimenting with uh, can't really be called engineering. It's more like prompt experimentation at best. So, in order to delve into some of these experiments, I'm going to illustrate how we described a set of tasks that we're going to use prompt engineering to try to improve. And one of the main concepts that we need to understand here is what's called the jagged frontier, and this comes out of Del Acqua et al.'s 2023 study. The jagged frontier describes how in tasks of equal perceived difficulty, that is, a series of different tasks that seem to be about as difficult as one another, AI is more capable in some areas and less capable in others. And it may not be apparent based on the task itself whether AI is going to be capable of it or not. And for prompt engineering to really show up, we have to be working um, beyond the frontier of capability. We need to be pushing the AI model to try to do things that it can't easily do so that we can uh, produce prompts that improve the output. So we're looking to work at the edge of what the AI can produce. Um, so this is what we're trying to create a set of instructions that were simple and straightforward enough that we could focus on a small number of steps, but not too complicated that it left the large language models, um, you know, nonplussed or stuck. We did earlier work with FlowFlex, a FlowFlex brand COVID-19 home test, and those instructions were just far too complicated for this type of illustrative experiment. And an additional problem with that set of instructions was that the medical equipment that was depicted in the instructions was proprietary, and so it kept throwing up content policy violations that prevented image generation. But these are the 4 steps that we're trying to produce, and I was trying to uh, prompt the AI to create a set of illustrated instructions similar to what you see on the right-hand side. This is copyright from John E. Sherry, 2017. And these are some text instructions that Claude 3.7 produced by looking at a finished version of the knob, which is something that I'll mention a little bit later. So these are some of the prompting strategies that we've been experimenting with, as well as some others, but these are some of the major ones. We would start our experiment to produce those with a 0-shot prompt. So I would prompt the model with no examples. It's known as vanilla prompting, and just prompt it to produce a set of instructions for tying a cleat hitch knot. The top row, the 0-shot, the 1-shot, and the few-shot prompting strategies all focus on the number of examples that we give. And I tried giving, internet examples and having the models go search the internet. I tried taking my own screenshots and uploading those as reference images from various sources. And I tried creating my own vector images of the knot steps to see if there was a difference between the photographs that I grabbed off the internet or like actual vector images or SVG images to see if the models could parse the code better. And we looked at in the bottom row different modes of prompting. So iterative prompting is prompting in a series where we change prompt after prompt. Chain of thought prompting is breaking a complex task into subtasks. and we used automated prompting to get the AI to produce its own prompts or its own chain of thought prompts, uh, which is really where most of the success, if you can call it success, is to be found. So these are some of the results that ChatGPT produced. I just want to skip back really quick and show you. If you look at number 4 here in this illustration, that's the knot that we're trying to produce. And this rope sequence is really the only way to correctly tie a cleat hitch knot. You can see here we have a number of fantastical examples. We probably ran through 4 or 5 dozen different prompts at least using Claude 3.7, ChatGPT 4.0 and 4.5, Photoshop, Illustrator, Sora, and we were not able to produce a single correct knot, let alone a sequence of steps that produced correct knots. Even when the models were instructed to produce one step, they wanted to create sequences of steps. They had very extreme difficulty producing top-down views. These are some of the outputs created by Claude. Claude uses an SVG engine to produce graphics, so you can see they're more rudimentary. I did eventually get a nice cleat hitch, kind of, based on a drawing I gave it, but it couldn't do anything with it. As you can see below that, when it tried to add a rope, it couldn't. And these are some of the best instructions that Claude could produce. Photoshop's generative AI was not any better. Sometimes it couldn't even produce a deck cleat, like you see on the right-hand side of the screen. I don't know what that is, a suitcase-sized dock, I guess. Yeah, so some more fanciful results. And then the videos that Sora produced were even stranger. As you can see here, simply impossible physics. And there were also some strange hallucinations when I tried to create a Sora video from storyboards using the images. It hallucinated this man for some reason at the end of the video. So these were about the best that I was able to eventually produce after, probably 36 hours of intense work trying to get these models in any way that I could to produce workable instructions. You could not correctly tie a cleat hitch following these instructions. And I don't even think in some cases you could even have a rope that would do some of these things. So uh, ultimately, these experiments showed some significant difficulties. And I'd like to use the last minute here to talk about some pedagogical implications for technical instructions. We do see prompt engineering working, but only slightly. So the more I prompted and the more we tried different approaches, we did end up with slightly better results eventually, but they still were incorrect. The best strategies seem to be automatic strategies. So having the LLMs create their own prompts and their own sequences of prompts, even better, seem to work the best. And that's how I got some of those really good results at the end. Number 3, we're still a long way from accurate multimodal large language models that can produce accurate technical graphics. So there are numerous issues with reality, with physics, with descriptions. And really the biggest problem for incorporating prompt engineering strategies into a service course is that there's no feedback on these instructions. So I might sit for 8 hours trying different strategies and failing over and over again. And I have no idea after I issue a prompt what it was that I did wrong. And as we know, as writing instructors know, if you don't know what you did wrong, you can't revise it to make it better. And so it's really not an engineering process. Yeah, it reminds me of that old Far Side cartoon, stimulus response. And that's what I feel like we're doing here, is just sort of like poking at a black box and getting different results with no real idea of how our interventions yielded those results, which is extremely problematic for a service course environment. So ultimately, we do think we need to continue our experiments with prompt engineering. We need to continue to try uh, ways maybe that are not using the commercial interfaces, as Jeff mentioned in the keynote. Perhaps using some API calls and changing the temperature, we might be able to get some better results. Hosting our own models and training them or fine tuning them might be another way around this, and feeding them RAG documents and segmenting that data might give us some better results as well. So that's sort of like the next stage of our investigations here. But right now, I don't know about you folks, but I'm not comfortable rolling out a module on prompt engineering in my technical communication class, even if I do encourage students to experiment with it or play around with it. I just don't feel like I could get good results. So thanks very much. And we're happy to answer questions at the end.